Hello! In this lesson, we'll explore the first and the most important concept in game optimization, frame rate. We'll also look at several key ideas that will help us in the next sections of this course. These ideas will give us a better understanding of what it means to optimize a game, how to make it smoother or more stable. So let's begin. Most people know what FPS is, frames per second, but FPS is just a number. It doesn't really tell us what the problem is when performance drops. You can see 60 FPS, 120 FPS, or even 30 FPS. But that's not enough to understand what's really going wrong. Computers don't really know what FPS is. They work with time, not frames. FPS is just a result. It's a number that comes after measuring how much time the CPU or GPU needed to process one frame. So if you see an FPS number, it's just a result of how much time your system took to process frames. But it doesn't really help you to understand the exact reason why something went wrong in the frame. FPS always hides what's really happening. It gives you no clue about which part of your game is causing the issue. That's why, as developers, especially if you are building games professionally, we should not rely on FPS when analyzing performance. Yes, of course, we want the game to run at 60 FPS or 120 FPS on PC or consoles, but those are just target values. What we really care about is frame time, or milliseconds per frame. Okay, let's say you wanna run your game at 120 FPS. It's not accurate enough. Instead, we should say, I want each frame to take only 8.3 milliseconds or less. Why? Because if we focus on FPS only, and we say, okay, this frame just drop it to 10 FPS, so it doesn't help. We need to know how many milliseconds that frame took. The higher the frame rate in milliseconds, the worse performance. So for 60 FPS, the frame needs to complete in 16.6 milliseconds. We'll learn later how to split that time between CPU and GPU. In this course, we will talk mostly using milliseconds, not FPS, because FPS is only the result, while frame time is the true data the computer uses. CPU and GPU operate based on milliseconds. So for example, 60 FPS, that means 16.6 milliseconds, and so on. These values are fixed. You can always calculate them using FPS equal to 1000 divided by frame time in milliseconds. When your system shows FPS on screen, it's actually calculating it from the frame time. So frame time is the real metric, and FPS is just a converted number. That's why our goal in this course is not just to get high FPS, but also keep the frame time stable throughout the game. Big studios or even events like GDC or Unreal Fest, you will notice that everyone talks about milliseconds or time budgeting. They don't say our game runs at 120 FPS. They say we budgeted 8 milliseconds for the GPU, 6 milliseconds for CPU, and so on. Now let's talk about tick. A tick simply means what happened in one frame. Every frame has a tick. It's when Unreal Engine updates everything. Movement, physics, AI, etc. Delta time is the amount of time between the current frame and the previous one. When you are debugging performance, you are actually looking at what happens in a single tick, how long each frame takes. For example, let's say in one tick, the CPU takes 8 milliseconds and the GPU takes 16.6 milliseconds. These are just simple numbers. We'll go deeper into how to measure and understand them in the course. But what matters now, the frame time for this tick is the highest of CPU or GPU, in this case 16.6 milliseconds. Okay, CPU comes up from things like blueprints, C++ logic, etc., and GPU is from 3D assets, materials, lighting, shadows. And this course will focus on GPU side, how to optimize assets, lighting, and more. We'll talk about blueprints and C++ optimization in a separate course. Again, remember, the system measures frame time, then converts it into FPS just to show players something simple. Players care about FPS, but we, as developers, care about milliseconds. Let's say we analyze the GPU. We might see lights are, okay, let's say are well optimized. Nanite is slightly heavy, but shadows are very expensive. This means shadows are taking too much time per frame, increasing frame time, lowering FPS. By looking at these numbers, we can detect the real cause of these stutters. And we try to fix that. By using stat unit graph, It shows a real-time graph of your frame time. We'll also see how much time each part of the engine is taking. Unreal doesn't use FPS internally. It uses milliseconds because it's more accurate and useful. Later, in the profiling section, we'll learn how to identify and fix problems by reading these values. We won't go into deep C++ or blueprint optimization in this course, but we will understand how to spot the exact cause of performance issues using frame time. Alright, that's it for today. In the next video, we'll continue with more optimization concepts. And thanks for watching.